Alright, we're on to super FRQ 5, so integral defined functions. So the first thing we always want to do on these is make sure we know what function relates to what. So the first thing they tell us, g of x equals the integral from 1 to x of f of t dt. So then if I take the derivative of that, g prime of x is going to equal f of x. So we might as well note, since this is the graph of f, it's also the graph of g prime. And that's going to help us later on. So the first thing we need to do is figure out what does g of 5 equal. And they give us this formula right here, so all we got to do is plug into it. So from 1 to 5, f of t dt. Now this is asking for the integral of f. This is the graph of f. That just means find the area under the curve from 1 to 5. So that's all of this, and then this triangle. So if I look here, g of 5 is going to equal, we have a triangle here, so 1, 2, 3. Our height is 2 divided by 2. Then we have this triangle, and it's below the x-axis, so we're going to subtract. So 1 times 1 divided by 2. So really, this is going to be 6 halves minus 1 half. It's going to equal 5 halves. Then the next one I need is g of negative 5. So that's going to equal from 1 to negative 5 f of t dt. But notice that's in the wrong order, so it's really going to be negative 5 to 1 f of t dt. So negative 5 to 1, that's 1, 2, 3, 4, 5. We got this half circle and this half circle. So this is going to equal negative. This first one's going to be pi. Our radius is 1 squared, and then it's half a circle, so we divide it by 2. Now this next part is below the x-axis, so we subtract. Our radius this time is 1, 2. So pi times 2 squared over 2. And then we just got to simplify, so I'll distribute that negative. So it's negative pi over 2 minus, plus 4 pi over 2, because we distribute that negative, it makes it a plus. So really this is just going to equal 3 pi over 2. That's what g of negative 5 is. So we can write this. We might need it later. G of 5 is going to equal 5 halves. And g of negative 5 is going to equal 3 pi over 2. Oops, probably needed some of that. Hold on. I'll leave that. All right, next I need g of 4, so that's going to be very similar. G of 4 is going to equal from 1 to 4 f of t dt. So that's just the area under the curve from 1 to 4, which is that triangle. We've already kind of done that. It was a triangle with a base of 3, height of 2, divided by 2, which just equals 3. Then I have g prime of 4. So g prime of 4, notice this is the graph of g prime. So we just go to 4, which is going to be right here, and we need the y value. which is going to be 0. And then g double prime of 4 just means we take the slope at that point. So it's going to be down 1 over 1. Sorry. So it's going to just equal -1. So that's why it was important to label what's g prime. And then to get g double prime, it's just the slope. Okay, C wants to know everywhere where we have a horizontal tangent on G. So right away you should be thinking this is any time the derivative equals 0. And then we got to say if it's a relative maximum or whatever. So first one, horizontal tangent would be at -5. Then we have -1, 2, 3. Then I have 1. And then lastly, I have x equals 4. Then we need to say if it's a relative min, relative max, or neither. So this is all going to depend on if it's changing from negative to positive or positive to negative, whatever. So at x equals -5, notice we don't know what's happening to the left at this point, so we're going to say neither. X equals -3, changing from positive values to negative values, which means g is going to be changing from increasing to decreasing. So that's going to be a relative max. X equals 1 changes from negative to positive. Negative to positive is decreasing to increasing, so that's going to be a relative min. Then x equals 4, it's going to change from a positive to a negative, so once again we'll be back to this one here. So it's going to be a relative max. Okay, D wants us to find the absolute max and min. So let me make space over here. Absolute max and min. We should have this chart here. So x, g of x, and then we need our endpoints and all of those points we just defined. So it says we're going to find both, so let's just put -5, -3, 1, 4, and then our other endpoint of 5. Now I need g of all of these values. I've already found a lot of them. G of 5 I know is 5/2 from part A. G of -5 is 3 pi over 2, also from part A. G of 4 I found was 3. G of 1, if I plug that in, it's going to go from 1 to 1 of f of x dx, so that's obviously going to be 0. But then I got to find g of -3. I don't have that one yet. So I'm going to just do it. It's going to be -3 to 1 since I'm changing the order. And then my slope from -3 to 1 was down here. So it's going to equal negative, because it's below the x-axis, pi 2 squared over 2, which is going to just come out to a positive 2 pi. 4 divided by 2 is 2. Negative and a negative make a positive. So from this, we should be able to tell where our absolute max and our absolute min are. So we should have an absolute min at the point 1, 0. And then deciding what the absolute max is. So we know pi is roughly about 3. So this one's like 9/2. That's like 4.5. 2 times 3.14 is 6, which is higher than all those other ones, so we can say an absolute max at the point negative 3, 2 pi. Okay, on what intervals is G increasing? So here's where we're going to need that chart. Let me draw the chart. A lot of charts. So we'll have, I'm going to do this in terms of G because that's what we're worried about. So it should be decreasing, critical point, increasing, concave down, point of inflection, concave up. G prime's negative, 0 or undefined, positive, decreasing, change, increasing. So if we want to know where G is increasing, that's going to be everywhere where G prime is positive. So G prime is going to be positive from, whoa, that's not what I meant to do. So it's positive from negative 5 to negative 3. And then from 1 to 4, because that's everywhere where our y values are positive, since this is our graph of G prime. And we're going to say because G prime, which equals f of x, is positive. Now decreasing is everywhere it's negative. So this one's going to be from negative 3 to 1. And then from 4 to 5. Because, oops, G prime of x equals f of x is negative. Okay, where is it concave up? So that's going to be any time that G prime is increasing. So it's going to be increasing from negative 5 to negative 4. And then from negative 1 all the way to 2. And then we can say because f of x equals G prime of x is increasing. Then concave down. Negative 3 to 1. Oh, just kidding. I'm doing the wrong thing. Hold on. Concave down is where G prime is decreasing, so that's going to be from negative 4 to negative 1. And then it starts to decrease again from 2 to 5. Because G prime equals f is decreasing. Okay, then we want decreasing and concave up. So if G is decreasing, that's going to mean G prime is negative. Concave up means G prime is increasing. So I need to look for where it's negative and increasing. So negative and increasing would be this part right here. From negative 1 to 1. Because G prime equals f of x is increasing and negative. Okay, where does it have a point of inflection? So our point of inflection means change. So we're going to look for where it's changing from decreasing to increasing or increasing to decreasing. And that's going to happen a couple places. So first off, here it's increasing. It starts to decrease right here at x equals -4. Then it's decreasing, decreasing, decreasing until we get to x equals -1. Increasing, increasing until right here at x equals 2. And then it stays decreasing the whole time. And our reasoning would be because g prime of x equals f of x changes. Whoa, what did I do? From decreasing to increasing, or vice versa. Alright, now I need to find g double prime of -4, g double prime of 2, and g double prime of 3. And essentially what that means is that we just have to find the slope at each of those points. So my slope at -4, I just count over, it's right here. The slope at that point is 0. So g double prime of -4 equals 0. Then g double prime of 2, so 2 is right here. Notice how the slope is different on both sides, d and e, because it's not differentiable at that point. And then g double prime of 3. 1, 2, 3. We just got to find the slope of this line, so it's going to be down 1, 2, over 1, 2. So that's just going to be -1. All right, j. Here we're given a new function h, and we got to find h prime of 4. So this is going to test our derivative rules. So h prime of 4, actually let's just do the derivative of h first. So h prime of x is just going to equal g prime of 2x times the derivative of the inside, which is 2. And then the derivative of that -4 is just 0. So then we can find h prime of 4 is going to equal g prime of 8 times 2. And if you notice, we don't even have an 8 on this problem. This is a typo. I think this was supposed to be like the 4 was on the inside, but if they ever give you this, you can't solve it. If it was something that you could solve, so like let's say that it did ask you for, let's say that this was h of x equals g of 2x minus 4. So it was all on the inside. It would still be g prime of 2x minus 4 times the derivative of the inside is still 2. This is what I believe the problem was supposed to say. So now when I plug it in, h prime of 4 is going to be g prime of, if I plug in 4 there, it's 8 minus 4, which is 4, times 2. And then if I look up g prime of 4, it's right here. Since this is the graph of g prime, it's just going to be 0. That's what this problem was supposed to say. This one is supposed to be k of x, not kx. Let me do this one below. So if we have k of x, k prime of x, we need quotient rule. So low, d high, minus high, d low, all over the square of what's below. All right, and then I'm gonna plug in four. So then I get 20. G prime of 4 we said was 0. G of 4 we found up here somewhere. It was 3. So it's going to be negative 15 over 400 is going to be our slope. This question's weird. And then we have x equals 4, meaning we need our y value still. So y minus, we know g of 4 is just going to be 3. I'm sorry, we got to plug it in. So if I just need k of 4, it's going to be g of 4 over 5 times 4, which is 20, and we know g of 4 is 3. So our y value in this case is 3/20. So y minus 3 over 20 equals negative 15 over 400 times x minus 4. That would be our slope. Our line tangent. Okay, next one. If I plug this in, I would get 2 times g of 2 minus 2, 1 squared minus 7 plus 6. G of 2, remember, was just, thought we found that earlier. We didn't find it, but it's this area under the curve from 1 to 2. So our base is 1, our height is 2. So it's 2 divided by 2 for the triangle, which gives us 1. So this is going to be 2 minus 2 over 0. So I get 0 over 0. So by L'Hopital's derivative, so the limit as x approaches 1, my derivative of that is going to be 4 g prime of 2x divided by 2x minus 7. So now when I plug it in again, I'm going to get 4 g prime of 2 over 2 minus 7, which is negative 5. So g prime of 2 equals 2. So it's really going to be 8 over negative 5 would be our answer for L. Last one. We have m of x equals all of this. So first off, it says find m of 1. I'll just replace all the x's with the 1. So obviously this is going to equal 3. Then I need the area under the curve from negative 3 to 1. We found that so many times. It's just going to be negative 2 pi. So that's m of 1. Now m prime of x is just going to equal 3 plus, remember, derivative of an integral like that just becomes f of x. Then n prime of 1 is going to be 3 plus f of 1. And if I look at f of 1, it's right here, it should just be 0. So it's just going to equal